Hello and welcome to our lesson on trigonometric ratios. Today, we will explore some fundamental concepts that will enhance your understanding of right-angled triangles and broaden your mathematical toolkit. In this lesson, we will firstly understand the basic trigonometric ratios, sine, cosine, and tangent, and understand how these ratios relate to the angles and sides of right-angled triangles. We will then apply these ratios to solve various problems involving right-angled triangles. After understanding these ratios, we will dive into various examples to see how this new knowledge can be applied in different scenarios. In our previous lessons, you have familiarized yourself with Pythagoras' theorem and the properties of right-angled triangles. You've been able to identify and work with the sides of these triangles, finding missing side lengths when given enough information. With this solid foundation, we can introduce the concept of trigonometric ratios. Let's get started. Trigonometric ratios describe the relationships between the angles and sides of a right-angled triangle. Let's label one of the angles, which isn't the right angle, with the Greek letter shown, which can be read theta. For a right-angled triangle with angle theta, we can label three sides: the opposite side, adjacent side, and hypotenuse. The hypotenuse is the longest side opposite the right angle. The opposite side is opposite the angle theta. The adjacent side is next to the angle theta and touches it. Based on those labels, we can form three ratios. Sine is the ratio of the length of the opposite side to the length of the hypotenuse. Cosine is the ratio of the length of the adjacent side to the length of the hypotenuse. Tangent is the ratio of the length of the opposite side to the length of the adjacent side. You may find it helpful to use the mnemonic SOHCAHTOA to remember. SO stands for sine is opposite over hypotenuse. CA stands for cosine is adjacent over hypotenuse. And TOA is for tangent is opposite over adjacent. Now let's look at how to put this into practice. Consider this right-angled triangle with angle theta. We first start by labeling the sides. The hypotenuse is the 5 centimeters side. The adjacent is the 4 centimeters side as it's next to the angle. And finally, the opposite is the 3 centimeters side. We can therefore write that sine theta equals 3 over 5, and cos theta equals 4/5, and finally tan theta equals 3 over 4. We can use trigonometric ratios to find missing sides or angles in right-angled triangles. To do this, we can follow a step-by-step method to approach any problem. 1. Identify the given information. 2. Select the appropriate trigonometric ratio. 3. Set up the equation using the trigonometric ratio. 4. Solve for the unknown side or angle. Let's practice applying this to some examples. Let's start with an example where we are trying to find a missing side. Suppose we are given a right-angled triangle with angle theta equals 30 degrees and hypotenuse equals 10 centimeters. We want to find the missing side x. Remember our step-by-step approach from the previous slide. It is displayed here to help you. Pause this video and see if you can solve the problem. Okay, step 1 is to identify the information we have been given. We have been told the angle, the hypotenuse, and we want to find the opposite side. So we have an opposite and a hypotenuse. For step 2, we select the appropriate trigonometric ratio. We need the one which combines opposite and hypotenuse, so let's choose sine. Step 3 requires us to substitute our known values into this equation. Finally, we need to solve this equation. Using a calculator, find that sine 30 equals 0.5. We can then rearrange this to find that x equals 5 centimeters. If you aren't getting the right value when you type sine 30 into your calculator, it might be because you are on the wrong setting. Look up how to change the setting to degrees for your specific model of calculator and try again. In our next example, we will try to find a missing angle. Given this right-angled triangle side lengths 10 and 8, we want to find the angle theta. First, identify the information we have. Note that 10 centimeters is the hypotenuse. The 8 centimeters side is next to theta. Hence, we have an adjacent side and a hypotenuse. Because of this, cos is the appropriate ratio to use. Substitute in the values we know. We find that cos theta equals 8 over 10, which can be written as 0.8. To find the angle theta, we need to use inverse cos. This is a button which can be found on your calculator. On the calculator shown here, you would need to press the Shift button and then the cos button. But check your calculator to practice this. By typing inverse cos of 0.8 into your calculator, you can find the angle theta. So we find that theta is approximately equal to 36.87 degrees. Here's another example. Given this right-angled triangle with angle theta equal to 45 degrees and labeled side equals 5 centimeters, find the hypotenuse. We won't put the step-by-step guide up this time, so see if you can solve this problem without it. First note that the 5 centimeter side is next to 45-degree angle, meaning it's the adjacent. As we have a hypotenuse and an adjacent, CA is the appropriate ratio. Substitute in the known values. We can use our calculator to find the numerical value of cos 45 degrees, which is root 2 over 2. Then we can rearrange the equation to make h the subject. Typing this into our calculator, we find that h is approximately equal to 7.07 cm. Okay, now for our final example. Given a right-angled triangle with the labeled sides 6 centimeters and 8 centimeters, find the angle theta. Note that in relation to theta, the 8 centimeter side is the adjacent side and the 6 centimeter side is the opposite side. Hence, tangent is the appropriate ratio. Substitute in the known values. This leaves us with tan theta equals 6 over 8. We can then simplify 6 out of 8 to 0.75. We then need to use the inverse tan function on our calculator to solve for theta. Type this into your calculator to find that theta is approximately equal to 36.87 degrees. In today's lesson, we explored the application of trigonometric ratios, a crucial concept within trigonometry. We began by defining the three primary trigonometric ratios: sine, cosine, and tangent. These ratios help us relate the angles of a right-angled triangle to the lengths of its sides. Specifically, sine is the ratio of the opposite side to the hypotenuse, cosine is the ratio of the adjacent side to the hypotenuse, and tangent is the ratio of the opposite side to the adjacent side. We demonstrated how to use these ratios to find unknown side lengths and angles in right-angled triangles. By working through a variety of example problems, we applied these ratios to calculate missing values, ensuring a solid understanding of when and how to use each ratio effectively.